All right, so I have to yell so that I can reach my computer here. This is objective 4.6D. The topic is horizontal stretches and compressions. And your objective, you will be successful when you can identify and graph the parent function of a given function. You can identify and perform the horizontal stretches and compressions indicated, and you can describe the transformations in the correct order. Okay, so we're still working on unfreezing the screen, on the vertex form of any function that you're given, where you've got numbers that are outside the grouping symbols, you've got numbers that are inside the grouping symbols with the x. And these, when the equation's written in that form, you can use the transformations of the parent function instead of creating a value of table or a table of values. Okay, so really important, especially for your quiz tomorrow, is understanding the steps in which you transform a graph. Most importantly, when you are writing your descriptions. In your written descriptions, you have to follow the transformation order. So you work step 1 inside the grouping symbols. You're looking for horizontal shifts. You're looking for horizontal compressions or stretches. Then you're looking to your multiplication for your stretches and compressions outside the grouping symbols. Then you'll flip things over using your negations. Then you'll shift up and down. So make sure that you are following those steps when you are describing your transformation. Okay, going back, our focus today is going to be on the b term. Okay, the coefficient of your x, because it's going to horizontally affect your graph. Remember this for your quiz. The numbers that are outside the grouping symbols affect your graph how? Vertically. The numbers inside the grouping symbols with your x affect the graph horizontally. And if it's inside the grouping symbols, do we do exactly what it says or the opposite of what it says? Opposite. If it's outside the grouping symbols, do we do what it says or the opposite? What it says. Okay, so we've got it. So here we go. Today's focus is the horizontal stretch. So we're going to stretch our letters horizontally today. Stretch them out. So your graph's going to stretch horizontally. The points will get further and further apart, or they will compress, meaning that they will get really close together. So we're going to stretch our graph horizontally, or we're going to compress our graph horizontally. So yesterday I was using on the vertical stretch the little spring that's in your ink pens, the little clicker spring, you know, and if you hold it horizontally and you stretch it out, the little rings get further and further apart, right? And then when you squeeze it together, the little rings get closer and closer and closer together. So today we're looking at our points on our x points. Are they stretching further and further apart, or are they getting closer and closer together? So our step process is this. Step 1, we're going to identify the function family and graph the parent function. Why do we graph the parent function?
Because it's the easiest to graph.
That's right, because it's the easiest to graph. It gives us the basic shape. It's the graph that we're going to transform. It's our starter graph. Okay, after we do that, today's new information to identify the horizontal stretch or compression. So that's our B term that we've been talking about. So what we will be doing, because we are working inside the grouping symbol, is we're going to be doing the opposite of what it says. So we will be using the reciprocal. I can't fit the whole word, so I'm just going to write recip. The reciprocal of B to decide whether our points are going to spread out horizontally or if they're going to compress horizontally. Okay, so we're going to use the reciprocal of B to help us make that decision. Then step 3, we're going to look for any negations. If we have to flip anything over or reverse any points. So if A is negative, remember A is outside the parentheses, so that's a vertical action, right? So it'll reflect across the x-axis from top to bottom or from bottom to top vertically, okay? And then if B is negative, we'll reflect across the y-axis because B is in the parentheses, so it has a horizontal action. All right, after we do that, we will identify, I'm going to switch colors here, identify the vertical shift and make the final transformation to graph the function, and we will describe it in the correct order. Inside the parentheses, then multiplication and flips, then up and down shifts. Okay, so here I have just an example of the quadratic parent function with two b terms, with two terms that are the coefficients of our x squared. So let's start off by graphing the parent function of the quadratic. F of x equals x squared. Not sure why I put a parentheses around that. I think because I was going to start tucking numbers inside in front of the x. That's why I did that. So those parentheses aren't necessary. You understand that, right? So let's graph it. So 0 squared is 0. 1 squared is 1. And 2 squared is 4. And then, of course, since this is a parabola, we'll reverse that. Negative 1 squared is also 1. Negative 2 squared is also 4. And if you'll notice, the graph that I provided you has a pretty big horizontal stretch, but not a very big vertical stretch. Oh, no, we're just drawing the parent function. We're going to draw all of these solid. Okay. So, how does this work? Because these things are working horizontally, these numbers that we're working on, the 2 and the half, they're in the parentheses with the x. They're going to have an action of horizontal movement. So they're either going to come in closer together towards the center, or they're going to stretch further away from the center. So I think we should go ahead and just draw our axis of symmetry in here, because this is the line. This is our measuring tool. We're going to squeeze points horizontally either towards the center, or we're going to stretch the points horizontally away from the center. So let's take a look at this one. So right now, do we have an A term? It's 1, right? It's 1. And we have a B term, right? So that's in the parentheses. So instead of multiplying by 2, because we have to use its inverse action, we're going to multiply times its reciprocal, right? Instead of multiplying by 2, I can cut something in half or multiply it by half. So since our B is 2, I'm going to convert that to a 1/2. And I'm going to remind myself that this is a horizontal action. And I want to know it's a multiplication. So it's either a stretch or it's a compression. Well, it's a half. So is it stretching out or is it squeezing in? It's squeezing in. So we would call this a horizontal compression. So that means that all of our points horizontally are going to squeeze in halfway. So their distance is going to go half. So instead of going right 1, up 1, I'm only going right half up 1. These points are going to squeeze in to half the distance from that center line. Do you understand? We're bringing those points in. The next point here is 2, 4. But that's an action of going left 2 and up 4. So instead of going left 2, I'm cutting that distance in left, the horizontal distance in half.
So I'm going only half the distance horizontally. So this point is coming halfway in. I'll do the same thing over here. So we're pushing them. Those points are compressing. They're getting closer to the center line by half. Do you understand? No? It's a little tougher than yesterday, right? Okay. All of those points squeezed in. Their distances were cut in half horizontally away from the center line. Okay? I want you to imagine that I did follow the order of operations and I rewrote this equation. What happens if I square a 2x squared? What's 2 squared? Okay. Once I get rid of the parentheses, what is this? An A or a B? It's an A. That's a vertical stretch by 4, right? We learned that yesterday, right? The vertical stretch times 4. So instead of going right 1 up 1, I'm going right 1 up 4. Look at that. Still on my graph. I'm still on my graph. So if you're really struggling with this B term, you always have that, well, not always, but most of the time you have the option of removing the parentheses. As long as there's not a shift in there. Getting rid of the parentheses and just using it as a vertical shift. All right, so let's go to this last one here. So we're going to graph this one. I'm going to change colors. And so this time our A is still 1. Our B is 1/3. So if B is 1/3 and I'm working in the grouping symbol, I have to multiply it times its reciprocal, which is times 3. So is that going to be, and that's a horizontal action, and it's times 3. So am I stretching those points out or am I squeezing those points in? So this is a horizontal stretch by 3. So what I'm going to do with this point right here at -1, 1 is instead of having a distance left 1, I'm going to triple that distance. So what's -1 times 3? So I'm going to spring it out 3. So it's going to stretch instead of 1 away from the center line, 3 to the left of the center line. So it's pushing outwards from -1 to -3. It's pushing outwards from +1 to +3. So it's a triple action horizontally because you're going out 1, 2, 3. Not pushing it up or down, pushing it out. All the points are pushing away. So if this one's out 2 points, yes? I have to go out 2, 4, 6. It's way out there off our graph. So these points are pushing away. So we won't graph those top ones. We're just going to go ahead and stretch through the points that I provided you. Okay? So you can imagine with the blue graph that you took the black graph and you held on to it and you squeezed it in until all of your x's were half a distance. And then you took your black graph to the red graph, you held on to the black graph, and then you pulled it horizontally out 3 times as far. Let's do your descriptions. We took f of x equals x squared for our blue graph, and what did we do with it? Horizontally compressed it by a factor of half. That's what we did. And then with our red graph, we took the parent function, x squared, And we used its inverse of 1/3, which was 3. So we horizontally stretched it by a factor of 3. I didn't mean to write the word it. Mm-hmm.
So if it's less than 1,
Yeah, as long as its reciprocal is less than 1, it's compressed. The reciprocal is greater than 1, it's stretched. Yes, because you're always doing the opposite. Okay? You're welcome. All right, so let's go on to the back. And we have here something similar to the quiz you'll be taking to get out the door today. And it's an actual quiz score, mini quiz, 3-pointer. So if you don't get it, you better ask questions, kind of quiz. Got it? All right, so here we have what we've been doing. Graphing the parent function in dash black and then going through the process. So what's the parent function here? F of x equals absolute value of x. Okay, what you'll notice here on my graph is that my graph is going by 2's. I think it would be nice if we went ahead, because we're going to be doing some compressions, to go in there, put tick marks on the odds, so 1, 3, and 5, just so that you can see them and pay attention to them as we do our, I think we're going to do a stretch here. Okay? All right. Yeah, we're going to dash. So let's graph the parent function. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. 3 is 3. I think we can just go up to 5 and negative 5. Then graph your parent function. In a dashed line. Okay. And now we're going to switch to the next thing. So we're going to work now. Order of operations states that we work inside the parentheses. Does this one have a shift in it inside the parentheses, a horizontal left or right? No. It only has a horizontal stretch or compression. So are we doing the negation yet? No. So we're just going to do working inside the grouping symbols. We're going to stretch this graph, right? Because it's a horizontal action in the grouping symbols. So we use the inverse. We're going to horizontally stretch by 4. So all of our points are going to stretch 4 spaces further out from the axis of symmetry here. So this point right here at negative 1, 1, instead of going left 1, it's going to go left 4. Because it's got to go out 4 times as far. So negative 1. So imagine 1, 2, 3, 4. It's 4 jumps away. So how about this 2 then? It's going left 2, 4, 6, 8. So it should be way out there. And then, of course, reflect that on the other side. So we'll go out to 4 up 1. And then we can't off the graph there. So that's it for that one. Just draw your dotted lines or your dashed lines. And there you have your stretch, your horizontal stretch. I'm going to erase this little lines I was making. Okay, so we've done everything that we were given inside the grouping symbols. So now we move outside the grouping symbols. So are we going to do our negation first or our shift? Negation, because we should always multiply before we subtract. So we're going to graph the negative. So that's outside the parentheses, a vertical action. So we're going to reflect it across the x-axis. So we're going to flip it upside down. So these points are going to reflect this direction, down. Awesome. And then lastly, we have flipped, we have stretched, we now are going to shift. Outside the parentheses, vertical action, it says everything subtract 3 from everything. So that means push everything down 3. So this is going to go down 1, 2, 3, 1, 2, 3. Vertex goes down to -3, 1, 2, 3, and a solid line because we finally have transformed the parent function. And we've graphed the final. Okay, so description, which is part of your quiz. We took f of x equals the absolute value of x, and we did what with it first? We horizontally stretched by a factor of 4. Then we reflected across. So we reflected vertically. Could I just say reflected vertically? Okay, so I'll put a reflected V. And then we shifted down 3. And there you have it. And this would be an acceptable description by just making sure you're using capital letters to tell me what direction I'm supposed to go. Like you can tell me H for horizontal, V for vertical, U for up, D for down, R for right, L for left. Okay? All right, last one. This one will go pretty fast. So here we have a cubic function. So let's start with our base function, or our parent function, x cubed. And you'll notice, hopefully, that my graph is really zoomed in. And I'm not sure why I zoomed in more to the right of the graph than the left, but I did. So there you go. We're going to graph 0, 0. We are going to graph 1, 1. But we can't graph 2, 8. So what I'm going to do is I'm going to graph halfway in. So 1/2 cubed is 0.125. So it's just barely up above. So halfway to the right and up just a skosh. And then, of course, we'll reverse that to -1/2 cubed is -0.125. And -1 cubed is -1. So we are really just paying attention on this graph, basically to the turning point here. What's happening at the turning point? So we're really zoomed in. Okay? All right. So now let's start to transform the parent function. So next we are going to work inside the grouping symbol. So we're going to graph f of x is equal to quantity 2x cubed. So, yikes. What does that tell me? Horizontal action. It's a horizontal action for sure because it's in the grouping symbol. We're compressing it, right? By half. Because in order to make 2 1, so I can cube it, 1 cubed is 3, I've got to cut 2 in half. All right, so that means that all of these points are going to squeeze in towards the center halfway. So this point, instead of going right 1, up 1, is only going right half. And then this point that's down here at half, and then 0.125 has to go halfway in. So it has to scoot in to a quarter. So you see how those points are getting closer to the center line, right? Center line would be right here through your turning point. Let's do the same thing on the other side. This half needs to scoot in vertically to a quarter. And this 1, -1, has to scoot into -1/2. Do you have a question? Oh, I'm sure it wasn't.
No, it was like I didn't notice.
Oh, okay. So you can see how those points are drawing in, right? They're shrinking. They're coming inwards halfway. So you're bringing them closer to the center line. Okay, now we only have one more thing to do, right? We don't have any reflections. There's no negations. Last thing we have to do is a vertical action. Add 3 to all of them. So we're going to push all the points up 3. So your center point's going to come up, your turning point to 0, 3. And then a quarter, 1, 2, 3, 5, and a half, 4. And then, of course, reflect it and redraw it. I missed. Well, you get it. And there you have it. It's been totally transformed using your B term. Okay, so description, f of x equals x cubed, was first horizontally compressed by a factor of half. You got it. And then shifted. Come on. Up. Come on. 3. I got to fix that so it says the right thing. Okay. So, let's see. Homework tonight will be on Canvas, and it's problems number 47 through 60. Now, I know you have the assignment, but I want you to look at it on Canvas because the assignment has typos.